Welcome to Mind Stretch. This day, we're venturing into one of the most intriguing frontiers of modern theoretical physics, the holographic principle. Could our entire 3D universe, including everything we see and experience, actually be encoded on a distant 2D surface? Strap in for a mind-bending journey that challenges our sense of reality. First proposed by physicists Gerard T. Hooft and Leonard Susskind in the 1990s, the holographic principle suggests that all the information about a volume of space can be described on its boundary. Imagine a 3D scene projected onto a 2D screen. Except, instead of simple light tricks, the principle implies a fundamental aspect of how our universe might be structured. This idea stems from studies of black holes, where information about fallen matter appears to be stored on the event horizon. By extension, if black holes work this way, maybe everything else does too. It's as if the cosmic stage we inhabit is, at its most fundamental level, more like a hologram than a solid reality. The story begins with an unexpected insight. Black holes have entropy, a measure of disorder, proportional to the area of their event horizon, not their volume. This was a major surprise. It implied that the key to understanding what happens inside a black hole might lie in its surface, rather than in the immense 3D space inside. If this principle holds for black holes, it could apply to the entire universe. That means all the information that composes our 3D reality is somehow written on a 2D boundary at the edges of our cosmos. This radical shift in perspective blurs the line between what's inside and what's outside. Much of the theoretical backing for the holographic principle comes from string theory, which attempts to unify gravity with quantum mechanics. In a famous duality known as the AD/CFT correspondence, a universe in anti-de Sitter space, ADS can be described by a quantum field theory, CFT, without gravity on its boundary. In simpler terms, everything happening in a curved 3D space could have an equivalent description in a flat 2D system. No gravity, just quantum fields. Though our own universe is in ADS, many researchers believe these concepts point the way toward a broader holographic understanding of reality. If the universe truly operates on holographic principles, it forces us to rethink our everyday intuitions about space and time. Are we 3D beings in a 3D world, or just projections of information encoded elsewhere? There's also the possibility that this framework could solve deep puzzles in physics, like reconciling general relativity with quantum mechanics or understanding the nature of dark energy. By reducing the complexity of 3D problems to 2D mathematical descriptions, scientists hope to unlock new insights into how the universe works at its most fundamental level. Of course, the holographic principle remains theoretical. Critics point out that while we have strong mathematical models for special cases, like ad spaces, we still lack direct experimental evidence that our everyday world is literally a hologram. Nevertheless, advancements in quantum gravity research, experiments with high-energy particle accelerators, and precise measurements of cosmic phenomena could bring us closer to confirming or refuting the idea. Whether or not the universe is truly holographic, the principle has already inspired groundbreaking work, keeping physicists and cosmologists on the edges of their seats. Thank you for joining us on this deep dive into the holographic principle, a radical theory that blurs the lines between dimensions and challenges our concept of reality. If this episode made you question the very nature of existence, give it a thumbs up, share it, and subscribe to Mind Stretch for more insights into the cosmic unknown. Until next time, keep an open mind. After all, what we perceive as solid might just be the surface of something deeper,